So this is the last question for this bi-weekly contest. So question name is maximize consecutive elements in array after modification. So you are given a zero index array nums consisting of positive integers. You can increase value of nums any element by one. After doing that, you have to select some elements such that they are consecutive. So you have to find out maximum number of elements you can select. We can see that 3, 4, 5. This is a consecutive elements, but 3, 4, 6 are not. And similarly, 1, 1, 2, 3 are not consecutive. So, as this is a very lengthy code, I am going to explain it, and code will be written beforehand. So, suppose this is an array. You are given this array. I am writing like this. You'll understand later. I am going to trying to solve this question by intervals. People have used current next DP, but I am not using that. I'm going to the interval solution. How can we solve this by using intervals? So these are the intervals we are getting from the above. These intervals, the number are consecutive. These intervals are disjoint, and the last element of any interval is less than the first element of that interval, and the difference is more than two, not one. Otherwise, it will be consecutive and it will be merged. So we can see that. So here concept is that how can we find the maximum interval this and its previous ones give. I'm writing a DP for that. Let's see. For this interval, suppose 1 and 2, what is the size of this? 2 minus 1 plus 1. Suppose first, there are only 4 intervals. You can do this. First, 2 minus 1 plus 1. Size will be what? 2. 1 and 2. We're getting. But do we only have 1 and 2 in this? No, we have 1, 1, 2. You see that? So in this intervals kind of explanation, the way is that in the range, if there is any element such that it has more frequency more than one, then its bool value will be true. I'm taking a bool value for every interval such that it is true or not. For 1 2 it is true, for 4 5 it is true, for 7 8 it is not true. So 0, for 10 12 it is not true, like that. The intervals start, end, and bool value like that. So you will understand after it. So 1, 1, 2, what can you make? 1 will become 1, 1, 2, 1 will become 2, and 2 will become 3. So we can see it will become 1, 2, 3. Similarly, you can see that for this and below this, even if we have a duplicate 2, we can see that 1 will become 1, 2 will remain 2, and 3, like that. So for any element that is duplicate, we can always increase the size by 1. So we can say that plus bool value. Bool value. So answer is 3. Second one, we can see 4, 5 minus 4 plus 1 plus bool value. What is coming? 3. How will it happen? So we have what? 4, 4, 5. It will become 4, 5, 6. So is the answer 3? Is it correct? Answer may be true for this interval, but if we see the previous interval, what is it? Previous interval, we can make the original values of the previous interval 1, 1, 2. What will it become? Now let's see, like this. 1, 1, 2, previous interval. Previous interval will become 1, 2, 3. 1, 2, 3, 4, 5, 6. So full after using the full previous interval, answer will be what? 6. After joining it with previous interval. So third step. I will tell you later what are the rules for this joining and all. Third step, what we have, 7 8 and 0 bool value. So answer will be 8 minus 7 plus 1 into 2 for this interval. And then we see previous intervals. Its previous interval, what was that? 4 5 6. What will it become? No, it is 4 4 5. We are taking the original value, so you will understand later why I am doing this. So it will become 4 5 6, and then 7 8 from here. The 7 8 of this interval and this interval. And also we have first one. This will become 1 2 3. So 1 2 3 4 5 6 7 8. We can see that for this one is coming 8. Next one, fourth. Fourth one we can see 10 to 12. What is this? 2 length. So 2 length we can do, no, okay, no, not 2. It's 3. So it's 10, 11, 12. For the previous one, we can see that we have only 7 in it. 7, 8 will, we may make it what 8 and 9. It will become consecutive. And we do this for the previous ones like this. 4 4 5 we have 4 4 5. What can we make? At most we can make 5 to 6. Suppose we maximize everything, what will happen? 4 to 5, 5 to 5, 4 to 5, and 5 to 6. There's no 7. We can't connect this and this. There's no connection between this and this. We can connect this one with its previous one. So there are some rules to follow. According to bool values, there are some rules. If the difference between the last interval and the first interval, current intervals first one and last intervals last one is 2, there are two cases. We can join them on conditions. So let's write the conditions. Difference, suppose interval, this is a comma b, and second interval c comma d. If b plus 1 equal to c minus 1, we can see that. So means what? If we increase b by 1, it it may become the previous element of c, so it may be consecutive. So what can we do? It can merge. Okay, so merging conditions. First one, there are some merging conditions. If bool value previous is true, if bool value of previous one, this a to b interval is true, then what can we do? We are not affecting a to b interval in any way. We are just making and inserting a c minus 1, suppose, or a b plus 1. We are inserting this here. From this we are getting this, okay. And then c to d. C2d, if C2d has some bool value also, then we will get a d plus 1 similarly, like that. So we are not affecting this a to b interval anyway. So we can say that whatever a to b access has access to, whatever the a to b has access, we can access this. So if previous bool value true, then current is equal to current length plus previous previous access, we can say, whatever access the previous one has. But if current bool value is false, no, previous bool value is false, then what can you say? Current equals to current length plus only previous. No previous access. Whatever previous has access, those we can't access. We can only access the previous ones. You can see first case, if the previous bool value is true, it is true for second and third cases. In second case, you can see that we are taking the previous ones and okay, no previous ones are there. So third case, we can see that this one, we are taking this one, and this is not affecting, we are shifting it such that it is not affecting this interval 4 5 6. This is not affecting interval 4 5. So we can take the previous ones also, whatever it is connected to this. So we can say that is a full connection, partial connection. This is fully connected with this, and then this is fully connected with this. But in the last case, we can see that 10 11 12, we have to but shift interval by one full, so that it can't access the previous one. There is no 7 here, we can't make 7. 4 4 5 will become 5 5 6, but there is no 7, so we can't access its previous ones, but we can access this one. So we can say that this has a full access to this, not, we can say partial access. Partial access means this will only access this, but not whatever it has. So we can see the code for this. Okay, so we are using a map, first taking the frequency, and then according to ascending order, the unique elements we are taking. For intervals, I said starting element is there, current element is there, and starting bool vector, if starting element has frequency greater than 1. So we are starting from I1. We can see if current element plus 1 is equal to that TMP at index I, we can see that current element we can increase, and bool vector, we can see bool variable, we can see, we have to find if any in the range can have a frequency greater than 1. So we can use or in the range. So or, but if it is not true that it is not current element plus 1, so we can push that start current and bool variable. If it is true, or otherwise false, and then we will initialize our new start element, current element, and bool variable. So similarly, this is for the last interval, so that it can be pushed. Okay, so now we are making a DP of intervals. You see that a DPI is intervals plus bool variables. Just simple. I said here in the first case, simple. And if I is not equal to 0, how can we see that if we can access the previous one? If we can't access the previous one, we can't even access the previous to previous, something like that. Sorted, everything is sorted. So last intervals plus 1 equals to this intervals first one minus 1. Then there are two conditions. If previous one's bool value is true, then we have full access to whatever that has. Otherwise, we have only access to the previous interval. So this thing. Okay, you can understand this code. Okay, let's try to run this. Okay, so you can see that try to understand this thing. If you want, this is a very simple logic. This is a very big code to write. This is not recommended in CPU contest. There's another DP method, the current and next DP. There's some 4 5 lines code. It's very easy that you can also see. But this is an intervals method. How to do is intervals. If you interview someone asks for another method, you can try this. Say this requires what understanding that DP method you may have to use what map or what map for the current element, but in this you don't have to use a map or something because we are using intervals. We are perfectly using everything on intervals. So okay, if you like this video, please subscribe to my channel. Thank you.